Hey guys, it's Ms. Marfleck here. We're going to be talking about inequalities today. We do pair inequalities with inverses in the same packet for the pre-calc class. There are a few different types of inequalities, and I have them listed here: our linear, our absolute value, our quadratic, and our rational. Now with this time kind of restriction on us, and we really are only meeting every other day, I want to get through this Algebra 2 review as quickly as possible, and we are almost there. And I just want to get started on the calculus and get started on limits because I did start that with my class last year back in the first week of April. So because of that, I'm telling you all this because we're not going to do quadratic and rational inequalities, but they exist and they're a thing. And if you do have time, I would really love and appreciate if you can just look up quick some videos on Khan Academy. Just type in quadratic inequalities, solving rational inequalities, especially if you're somebody who wants to pursue math in the future. These two inequalities are very special, and I actually love teaching them because we factor the quadratic inequality. We see, where our zeros are, -3 and 4, and then we pick some test values over here. We plug it in, see, oh, it's greater than, or all these answers in between here are negative, all these answers in between are positive, and then we're able to use kind of like this little graph to help us write our values in interval notation, and it can be really confusing, but this method, or kind of like this scrap work, this process that's used for solving quadratic and rational inequalities, you will definitely see in calculus. We use this with critical numbers and finding concavity. We use it in our first or second derivative test, whatever, but this is something you will see again, and I would really love it if you had some time, if you could check that out. So today we're just going to be doing linear and absolute value. Linear is, I think, pretty easy. We've seen it. And absolute value has kind of like a lot of rules and can be a little tricky, so stick around. All right, and then one thing to just kind of recall from Algebra 2 or, Algebra 1 is that when you're working with these inequalities, you have to keep in mind whenever you are multiplying or dividing through by a negative number, you have to flip the sign. Now, you can add or subtract a negative number, and you just keep the sign where it is, or you could have a negative number on one side and you just keep the sign where it is. But when you are multiplying or dividing both sides of an inequality by negative number, you have to flip the sign. All right, the first type of problem or inequality that we're going to start off with is our linear inequality, and we're going to go through this one pretty quickly, and our directions are just to solve and write in interval notation. Solve and write in interval notation. Okay, and then here's going to be our first one. Number 1. We have 3 minus 2x is less than or equal to 11. Switching colors here, denoting or changing the color from problem to answer. All right, we're going to solve this for x, which means I want to get x by itself. So the first thing I can do is subtract 3 on both sides. And then here's that illustration of dividing on through by a negative flips that inequality sign. And then now we have x is greater than or equal to -4. And I'm writing that in the interval notation, and it can be equal to -4, so it's inclusive. So you could solve it this way, or you could solve it a different way that kind of avoids the flipping of the sign. You could solve it by adding 2x to both sides, and then subtracting 11 from both sides, and then now when you divide by a +2, okay, you don't flip the sign. And this is the same, okay, -4 is less than x, is the same as x is greater than or equal to -4. It's the same thing. And then I'm just going to box this in here. Please excuse my sniffling. I am a little bit under the weather. I think it's just allergies, though. All right, here we are. Number 1 is done. All right, and then another example here of a linear inequality, meaning x is to the first power, just a little different. You can see now we have x on both sides of the equation. But that doesn't change much of anything. You do just have to get all the x's together on one side and then isolate, and then now I can divide by 3. And then now I can read here that -3 is greater than x, or sometimes I like to put the x first. X is less than -3, which means my interval is going from -infinity to -3, and I can't be -3. I'm exclusive of -3. All right, and then we're just going to take a look at one more type of linear inequality, and that's going to be our compound. I'm only going to do one example because you've seen compound inequalities before, and you've seen them when we did graphing trig functions. Now, you may not remember, but when we graphed our trig functions, when we did tangent and cotangent, you had to use this type of compound inequality to solve for the asymptotes. And what we basically did was we isolate, ooh, I wish I had whiteout. Oh, my notes are going to be so ugly. Do I have any whiteout? No, I don't. Believe it or not, it's really hard to talk and write at the same time, especially when you're writing something and talking about something different. Okay, but anyway, when we worked with our tangent and cotangent graphs, what we did was we used this to solve for our asymptotes. So it's the same process as solving for the asymptotes. You isolate the x on the inside, so when you subtract 1, you have to do it from both sides. So I'm subtracting 1 from both sides, and then now I'm dividing by 2 on both sides, and then now I have my inequality, and it's already kind of set up for the interval notation because it has the endpoints. And then not inclusive of the -2, and then I am inclusive of the 1. And then that's going to be it for our linear inequalities, and now we're going to move on to our absolute value inequalities. Even though I have some room at the bottom of my paper, I do recommend that you start on a fresh sheet because these rules are a little bit lengthy, and it's good to just have them kind of all together. All right, now we're going to take a look at our absolute value inequality. Now, I'm going to start by saying that I do think this is obviously the harder of the two. Once you throw in that absolute value, you start posing some issues because the negatives are a reflection of positives. These rules can be very confusing at first, and I think they're best illustrated with numbers, but please write them down because you're definitely going to need these rules to get through each problem, okay? You're not going to just memorize them off the top of your head. I even very quickly looked at the pre-calc book before I made my notes for this lesson, so, you really need to have these written down somewhere. And we're going to start off these notes for our absolute value inequalities by letting this capital X be an algebraic expression. So it's not just representing one number like usually our lowercase x does, but it's going to represent an entire algebraic expression. So it could represent a 2x plus 5, a -3x minus 4, and x squared, but nonetheless an algebraic expression. And then we're going to let this lowercase c be any positive number. So we're assuming for all these conditions that it is positive. And then we're going to have these multiple cases or these different scenarios that we could have with the absolute value sign. And then I'm going to tell you what the solutions are in these scenarios. All right, we're going to start off with number 1. And the first scenario is that the solution of our algebraic expression absolute value signs is less than a number, or you take it out of the absolute value signs, and that expression is between -c and +c. Our second condition is very similar to the first one, except now our signs are flipped around here. And when the absolute value of an expression is greater than a positive number, we have everything inside the absolute value sign is greater than that number, or everything inside the absolute value sign is less than that negative number. Almost done here. I think 3 and 4 are probably the easier ones to understand. So here, the solution of the absolute value of x is less than a negative number, or no solution. So when you think about it, I'm asking you here, when is the absolute value of a number less than a negative? Well, absolute value is always positive. It's never less than a negative number, so there's no solution here. And then now number 4, we're going to flip number 3 around, and when we have the absolute value is greater than a negative number, then every single x value is a solution. Our answer is all real numbers. And then if you think about it, when is the absolute value of a number greater than a negative number? Always. Okay, so this one's a never and this one's an always, because no matter what number's in here, it will always come out positive with that absolute value sign. All right, now I said these conditions are a little bit confusing. I would love to kind of just describe them to you, but I think they're better understood when we do them with really, really simple numbers. And that's what we're going to do for the first 4 problems before we amp it up for another 4 problems. All right, and then I just want to let you know that all these conditions hold true when you have this less than or equal to or the greater than or equal to. It's the same rule. So I know in the definition we used, just a less than or just a greater than, but it's the same rule for this. And then just so you could see here, I did write all these conditions on a sticky note, and that's what's going to help us get through these problems, okay? All right, now our directions are going to be the same as the last few problems we did, and it's going to be to solve and write in interval notation. And those are our directions here. Solve and write in interval notation. All right, here we are. We're going to have this first one, and we have the absolute value of x is less than 4. Okay. So when I know I can look at the conditions, but first I want to just talk us through here. I'm looking to see numbers less than 4. Okay, well, if I plug 3 in, it's less than 4. If I plug 2 in, it's less than 4. If I plug 1 in, it's less than 4. If I plug 0 in, it's less than 4. If I plug -1 in, I have the absolute value signs. It's a +1. +1 is less than 4. If I plug -3 in, I have my absolute value signs, and that is also less than 4. So -1 works, -3 works. But then when I go to something like -5, and I plug -5 in, and I do the absolute value sign, it comes out +5, and that's not less than 4. So -5 is not a solution. So any number less than -4 is not a solution, and any number greater than 4 is not a solution. And then now I can just think about these rules here, and I know you can see them at the top of the sheet, so I don't need to use a sticky note right now. And I'm going to tell you that this is a condition 1 problem. I have the absolute value of an expression, which is x, is less than a positive number c. So I'm going to rewrite this as -c x, everything inside the absolute value signs, is less than c. And then this is my solution set, just kind of like we verbally talked about a minute ago. And now I can write this in interval notation, and I have x's between -4 and 4, and it's not inclusive of either one, and I'm just going to box in that answer there. All right, so hopefully after this one, you believe the first condition, you're kind of convinced. I know it's weird maybe seeing it with all the variables, and hopefully here this illustrates it a little better. And then now we're going to move on to our second type of problem, and that's absolute value of x, let's say, is greater than or equal to 2. All right. Well, I can look here and say, okay, what condition is this? Okay, this is condition 2. Absolute value is greater than c. So then I have to split these two up, okay? I have to split it up as, so this is condition 2, as x is greater than or equal to c, or x is less than or equal to -c. And then in this problem here, our c is 2. Okay, you see that? Our c is 2. And then now putting in those inequalities that we started with in the problem. So now we have these two, and I can write them first separately as answers. So let's see, x is greater than 2, and it can be equal to 2, or x is less than -2 and can be equal to -2. And then now I can write them as one big solution set, and then writing them in order from least to greatest, and then now boxing that in because that is my final answer. All right, so now hopefully you believe condition 2, and we're going to move on, you guessed it, to the third one, 3. All right, and we're going to have absolute value of x is less than or equal to -3. All right, so I'm going to ask you when, okay, this is a positive answer, okay, because the absolute value signs makes it positive. So I'm saying, when is a positive less than or equal to a negative? That is a never, okay, never. Which means that this is a no solution, okay? That never happens. This is a no solution. And then looking at my conditions, I could see that this is a condition 3 statement. Absolute value is less than a negative number, no solution. So I didn't even really need to think through that. I could have just used these conditions here. All right, and then I'm really gonna squeeze in this number 4 here. And that's going to be absolute value of x is greater than or equal to -7. So I'm asking you, when is a positive number greater than or equal to a negative number? And that's going to be an always statement, which means our answer is all real numbers. But I asked you to write it in terms of interval notation, which means we're writing -infinity to +infinity. okay? Negative infinity to positive. And then looking at my little sticky note here, this is a statement for condition, okay? X is greater than negative c, then all real numbers. All right, this may have looked, maybe you're feeling a little confident here, okay? So this was to help us understand the rules, and these are not the type of questions you're gonna see on a Quizzy or something like that. Now that we're moving on, these are the types of questions you can expect to see, and we're going to amp things up just a little bit, and I only got 4 more problems for you, okay? And here I am, this one's going to be number 5. So I have absolute value of 2x minus 5 is less than or equal to 7. All right, this is where it's really helpful to have these conditions here, and I'm asking myself, okay, which condition is this? This one is a condition 1 statement. Absolute value is less than c, which means I'm going to have negative c, x, and then c. And I have those lines under our inequality from the problem. So this is a condition 1 problem, and now I could switch colors and I could start solving. So this is negative 7 is less than or equal to x, and our x here is 2x minus 5, and then that's less than or equal to positive 7. And then now we have that compound inequality that we saw during trig, and we're solving by doing the same thing to both sides. Now I have to divide by 2, and now I can see my answer is between 1 and 6, and is inclusive of 1 and inclusive of 6. So once you've identified what type of problem it is, then you just follow the rule and then solve for x. All right, there's number 5. 3 more to go. Here I am, number 6. We have absolute value of negative 3x plus 2 is greater than 7. All right, and then I'm looking here and I'm trying to see, okay, which condition is this? And this is absolute value is greater than a positive number. All right, absolute value is greater than a positive number. Okay, that means then I have x is greater than c, or x is less than negative c. All right, and then c in this problem is going to be 7. So we're going to have negative 3x plus 2 is greater than 7, or negative 3x plus 2 is less than negative 7. And then now we're going to go ahead and solve. I'm going to subtract 2 from both sides, and then watch, I'm dividing by a negative 3, so that sign is flipping. Okay, divide by negative 3, sign is flipping. And then now I'm solving this right inequality. I'm going to subtract 2, and then once again I'm dividing by a negative 3, and that sign is flipping as well. All right, now it's time for interval notation. X is less than this number, so I'm coming from negative infinity and I'm going up to this number, and I'm not inclusive of negative 5 over 3. And then I have another set where x can be greater than 3, also not inclusive of the 3, and there's my second solution. All right, so once I was able to identify that this was a condition 2 problem, it was really easy to get this inequality here. All right, 2 more to go. Here I am, number 7. We have negative 2, absolute value 3x plus 5, absolute value plus 7 greater than or equal to negative 13. All right, and then now we have a little bit more going on here. You can see that the absolute value sign is not isolated, and just looking at this sticky note, looking at our 4 conditions, the absolute value sign is always isolated. So that's the first step here. First step is to get the x by get the absolute value sign by itself, which means I'm going to subtract 7 from both sides, and then watch when I divide by the negative 2, the sign flips. All right, now that I've isolated the inequality, I can look and see, well, what condition problem is this? And I have absolute value is less than a positive number. Absolute value is less than a positive number. That's a condition 1 statement where I have negative c less than or equal to x less than or equal to c, condition 1. All right, which means my c here is 10, so I have negative 10 is less than or equal to 3x plus 5, which is less than or equal to 10. I have this compound inequality here. I can subtract 5 from both sides, and then I can divide on through by 3. Now the 3 is positive, so there's no flipping of the sign here. And then now I'm between these 2 numbers, and I'm inclusive of these 2 numbers. There's my answer in interval notation. All right, you've made it. Here's the very last one, number 8. And we're going to have absolute value 3x plus 2 all over 2 is greater than or equal to 2. Once again, looking at my very pretty fluorescent sticky note here, you could see all the absolute value signs are isolated. So I need to get this absolute value by itself, which means I'm going to multiply both sides by 2. Okay, and then now that it's by itself, we have a condition where absolute value is greater than a positive number. So that's going to be this condition, which means I have x is greater than c, it's an equal to, or x is less than or equal to negative c. So I'm going to write that out here where my c is now 4. So I'm going to have 3x plus 2 is greater than or equal to 4. Or 3x plus 2 is less than or equal to negative 4. And then now that I've used these two, I can go ahead and solve by subtracting 2 from both sides and dividing by 3. And then same thing on this side, subtracting 2 from both sides and dividing by 3. And then now I can take a minute and I can write these intervals separately. Okay, well, x has to be greater than this number and it is inclusive of this number. And then x is less than this number and it is inclusive of this number. And I'm going to write them in order from least to greatest. And then together with the union, now this is the answer, one solution set. All right, so once again, this can be a little bit of a confusing topic, but please, 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 where is it? Please, 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 just have the rules handy, okay? Have them handy when you're doing your quizzy, have them handy when you're doing, you know, your homework. We use the more basic examples over here to kind of illustrate that they work. Now that you know they work, you know, really just use them for every single problem. Now you're in luck. My class last year had to memorize these rules to take an assessment. Now that we're doing this remote learning, everything's open notes. So make sure you have that handy. All right. And then once again, if you're somebody who does have some free time on your hand, really go ahead and you know, take the initiative, to teach yourself something, you know, without me maybe forcing yourself to do math, okay? So take the initiative to look up a quadratic inequality, because I really would love to do that, but we don't have the time. And take the initiative to do some research on a rational inequality. And then you'll thank yourself later when you see these kind of weird looking charts in the future. All right, make sure you get to your homework and then email me if you have any questions.